Alright, so I think I figured out how to do cylindrical. So pretty much I think since I don't have an example, I think the only question they'll ask is like to change from spherical, I mean from a regular like integral like this to cylindrical and then spherical. So for in this problem they give us this integral, so 0 to 2, 0 to 4 minus x squared, 0 to that, and then z squared is our function, dz, dy, dx. So in order to do this, you have to look at the bounds, and this is where you have to draw it in order to like change it from cylindrical and then to spherical. So pretty much what you could do is you have to look at the bounds. So the bound says from 0 to 4 minus x squared minus y squared. So pretty much this, the 4 minus x squared minus y squared, it's a sphere, and it's the same thing as rewriting as z squared plus y squared plus x squared equals 4 with the radius of 2. If you was to draw that out, it will be along the z-axis. It's just a sphere. I can't draw a sphere, but imagine that was a sphere. It's centered at 0, 0, which is right here. It has a radius of 2, right? And so that's that sphere. That's your z-bound. But for the bound, it says from 0 to 4 minus x squared minus y squared. So that's pretty much this area right here that we're looking at for the z-bound. Now we have to look at the y-bound. We say the y-bound is from 0 to 4 minus x squared. Now this is where we have to draw the circle. We have to draw the 2D representation in the xy or the Cartesian coordinates. So we know it's a circle because if you draw a sphere in 2D, it's gonna be a circle. So since it's now we have to look back at bounds. So it says for our y is from 0 to 4 minus x squared. So our bounds is from 0 to 4 minus x squared, which is this. So we're just looking at this area. And now our x bound is from 0 to 2. So even if we use that, it would be 0 to 2, which is that also. I'm sorry. Yeah, 0 to 2, yeah, which would be that. Now in order to change it from this original dz, dy, dx, pretty much is the same thing like polar. The thing with cylindrical is that when you see z, you do not change it. So here you don't have to change, like replace it with cosine or sine or anything. So in this case, you just rewrite it. You remember how we had like we had x squared plus y squared, and we replaced it with r sine cosine. We don't have to do that. So when you see z, in this case, we have z squared. We just leave z squared. So that in that case, we don't have to change the z bounds. But we do have to change. We could rewrite this since we have, if we just look at this first integral, we have 4 minus x squared minus y squared. We know that x squared plus y squared equals r squared, so we could replace the negative x squared minus y squared with r squared. So we have 4 minus r squared. So that gives us our z bound. Now we have to change the y bound. So y is gonna be, how high you go, and then d theta is pretty much your angle. So now if we look at the 2D representation for the second bound, I'm sorry, so dy, which is 0 to 4 minus x squared, if we look at it, pretty much it's going from yeah, it's going from 0 to 2 because that's your radius. So yeah, dr would be 0 to 2, and then angle, which is d theta, which would be from 0 to pi over 2, because we only looking at this first region because we drew it from these bounds. So that's pretty much changing it. I don't know what other question they would ask, but just to tell you to integrate it, I think. Oh, and one more thing, for the cylindrical, you have to add a r. So in this case, it would be r times z squared dz dr d theta, and then now you just integrate with respect to z, and then you get r z cubed over 3, and then you continue on with that. So pretty much, I don't know how to explain it easier because this stuff is complex, so I'll send you a picture of this.